Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Saiful Hadi Osman. I'm from Bachelor of Chemical Engineering EH22 from UiTM Shah Alam Selangor. And today I would like to present about my research project, which are magnetic recycle alginate impression, photocatalyst for cationic and anionic wastewater. Thanks to my supervisor, which are Puan Sarina Fairuz binti Abdul Manaf, and my co-supervisor, which are Puan Nur Hashimah binti Alias. So today I would like to present about my introduction, my problem statement research, the objective of my research, the photocatalyst that I use in my research, the alginate impression material, the method that I use to prepare and synthesis my project, and the conclusion. Alright, the advanced oxidation process is an alternative technique used for destruction of harmful organic pollutants from contaminated water and air. This process involves the UV-based processes, chemical oxidation processes, or photophaton processes. Among the advanced oxidation processes, heterogeneous photocatalysis has been widely used and been studied because its principle involves the activation of semiconductor by sunlight or artificial light. Photocatalysis is a type of catalyst that results in the modification of the rate of photoreaction, which is a chemical reaction that involves the absorption of light by one or more reacting species by the addition of substance called catalysts that participate in the chemical reaction without being consumed. The issue related to my research project is about wastewater containing dye pigment. Globally, around 80% of wastewater flow back into ecosystem without being treated or reused, contribute to a situation where around 1.8 billion people use a source of drinking water contaminated with feces, putting them at a risk of contracting cholera, typhoid, and polio. Wastewater can be divided into two types, which are domestic wastewater and industrial wastewater. Wastewater produced due to the human activity classified as a domestic wastewater. For example, from the activity of bathing or laundry. Quite simply, industrial wastewater is a water that has been used for the making of commercial product. A study has shown that a textile wastewater can cause sickness, stress, and dermatitis. The chemical present in the water can block sunlight and increase the organic pollution in the water, thereby inhibit the photosynthesis of plant and reoxygenation. Dye is a substance used to impart color to textile, water, leather, and other material that it can be categorized into two groups, which are natural dye and synthetic dye. Natural dye can be obtained from the animal or plant without using any chemical processing, while the synthetic dye is manufactured from the organic molecule. Extensive discharge of dye into environment, especially into a river and ocean, can cause a serious issues because dye can remain in the environment for an extended period of time due to their high thermality and photostability to resist the biodegradation. Therefore, it can bring harm to the aquatic life and to the organism that consume the untreated wastewater containing the dye pigment. There are two main objectives of my research project, which are a synthesis of a photocatalyst based from the graphitic carbonitride with the alginate impression material for the removing of anionic and cationic dye from the wastewater and investigate the physical, chemical, and thermal properties of the magnetic recycled alginate impression material. Graphitic carbonitride is an excellent polymer photocatalyst to develop the semiconductor field and deprive solar photons from their energies for conversion into chemical energy, resulting in degradation of a number of hazardous organic pollutants into harmless compounds. The graphite carbonitride has fortified its application in the field of photocatalysis due to its unique nature, including high chemical stability, non-toxic, and suitable position of energy band. However, its relatively low visible light absorption, quick recombination of excited charge, and low surface area has overshadowed its full-fledged efficiency in the above means. Alginate is an elastic, irreversible hydrocolloid impression material, and it is one of most frequently used dental material. Because alginate impression is simple, cost-effective, and indispensable part for dental practice. This hydrocolloid can be used for preliminary impression, provisional crown and bridge impression, and also for study model. Alginate impression also used for impression in orthodontic models, spot mouthguard, and bleaching tray. The alginate impression material consists of a powder that contains sodium alginate, calcium sulfate, trisodium phosphate diatomaceous earth, zinc oxide, and potassium titanium fluoride. When mixed with the water, the alginate impression form become a salt, and later a chemical reaction takes place, thus the alginate impression become gel. Alright, for this slide, I would like to talk about the method that I use to synthesize the graphite carbonitride in a semi-closed system with an air atmosphere. The method that I use is called a facial thermal polymerization of urea. Firstly, 20 grams of urea is put into a ceramic crucible, dry at 70 degrees C for 12 hours, and then heat up the crucible to 550 degrees C in a muffle furnace for 4.5 hours with a RAM rate of 5 degrees C per minute. And then a yellow powder is obtained. The powder is washed with a nitric acid and deionized water. Then centrifugate the powder and dry it for 24 hours at 70 degrees C. Then the graphite carbonitride powder is obtained. Alright, for this slide, I would like to talk about the preparation of alginate impression graphite carbonitride through a method called the cross-linking polymerization. Firstly, 1 gram of prepared graphite carbonitride is evenly dispersed in 250 ml deionized water under ultrasound treatment. And then add about 1 gram of sodium alginate into the above solution while stirring it for 1 hour at the room temperature. Later on, add about 0.5 gram acrylamide and 0.02 gram ammonium persulfide into the solution and continue stirring for 3 hours at 50 degrees C. To reduce the temperature to 30 degrees C, 1 gram of epichlorohydrin is dropped into the solution as a cross-linking agent while stirring it for 24 hours. The hydrogen bonds are formed by adding the solution dropwise into the calcium chloride solution with the percentage of 5% weight to volume percentage and stir continuously. This will make the composite absorbent immobilized in the alginate capsule. To allow the complete immobilize, the obtained bed must be stirred in the presence of calcium chloride solution for 6 hours. Finally, the bed is firstly washed with the nitric acid to remove the calcium ion and later wash it with the ionized water several times before freeze dried for 12 hours. The graphite carbonitride with the alginate impression made by the cross-linking polymerization is successfully formed in the form of hydrogel. In conclusion, a low-cost and highly efficient photocatalyst can be made from the facial cross-linking method consists of graphite carbonitride with alginate impression material for removing the anionic and cationic dye from the wastewater. Thank you.